Thank you for having me. It's a pleasure to be here, see everybody's faces. It's really awesome to be to see my community here. I love it. So, for those of you who don't know me, my name is Zach Daniel. I'm the author of Ash Framework, which is a general-purpose application framework for Elixir. And today I'm going to be talking a little bit about some past, present, future about Ash. And first, I want to show you our star history chart. It's really nice to see the project growing. We've got backing. Lembic has very graciously supported the project. And all in all, I'm very pleased with where we are and the state of the community. I want to start with a story of a function. So this function that you see on the screen, this is a very simple function. It's a baby. It's beautiful, like this looks beautiful. This is like when you think of like awesome code, it's like nice, simple operations. And it's just so easy to understand. Nobody ever looks at this and gets confused. But it's grown up a little bit. Now it's a toddler. It's not as simple, but it's still simple. And I would say that this is already heading down a bad path. So you might be able to spot the sort of problem that's already evolving, but let's see where this can go. So this is an adolescent function. It's unpleasant. It's a handful, and it talks back. And so what I mean by that is like this function has opinions. It's got a lot of sort of knowledge embedded in the function. But okay, it grew up. It cleaned itself up. It's not quite so rebellious. But I would argue that its potential has still been wasted. All right, it suffers from its troubled childhood. And there are millions of functions like this out there. All of our apps are filled with them. And generally speaking, this is what I see applications are made of. This is the lifeblood of most applications out there. I'll take this over certain kinds of applications any day, right? This is not, if I see this, I don't go, oh my gosh, this is the worst thing I've ever seen, right? Like this is okay, but I think that we can do better. So I think that there are better ways and better building blocks to construct our applications with. So let's talk a little bit about composition. Imperative code enforces artificial boundaries. And that sentence is probably one of those that like flies in one ear and goes out the other. But some examples I think will help illustrate the issue. And I would like to point out that this kind of problem, what we're going to see here, exists in like all over the place. It's always there to some degree. And I would argue that once you see it, once you really get used to seeing this, you can't unsee the way that we build this into our applications every day. So let's talk about a really simple example for how imperative code adds a sort of artificial boundary, or an artificial boundary. It looks like I copied this slide a little bit wrong, but let's take a look at these are two computed fields, right? And you can see, like, it's hidden from you looking at this function, but there's a little bit of truth in there, which is that some computed field 2, it depends on the first one for whatever reason, right? It's derivative of the first piece of information. And maybe some developer comes in and he like does some shuffling of code around and he puts some computed field 2 above the first one, thinking like, why would that be a problem? They're separate fields for computing them. And then you get like something breaks or something's nil in your API or whatever. And this kind of thing happens all the time. But the fact that ordered mattered there wasn't necessarily like a requirement for the way that we build the world. Like, there are plenty of systems where you can declare dependencies between two things and like let it figure out the order that they have to go in, right? So it was our imperative code that caused this to be true, that made order matter in this operation. And yeah, this is the old bullet points from last slide copied into this slide. So simple or optimized, pick one. We have an intuition for this, right? Like we write our code, we optimize later because we are aware that you write code, you try to make it fast, you try to make it smart, And then it becomes really complicated, right? So we generally have to pick simple or optimized. And in this case, we've got these two little things we want to do. We want to be able to say, given some tweet query, only give me the ones for active users. And we also want to be able to say, only give me the ones that come from my friends. And in isolation, they're fine. But when you combine them, you're doing two joins in your SQL query. It's not the end of the world. I mean, it's definitely not the end of the world. But you're kind of just leaving that on the table. Like, that's just the way of the world. Pick one. Do it simple or do it optimized. And what happens is, this is what it looks like generally. There's plenty of ways you can tackle these things, but this is what it generally looks like to solve this kind of problem. So it's a lot more code, first off. This is doing the same thing, but it's just, if you look on the right side here, these like join functions, they are a kind of smart, by some definition of smart, version of like don't join unless you've already joined. And so now you can use these two bits, in whatever order and whatever query, and avoid you've optimized it. But first off, I mean, this is way more complicated, right? Like probably many people would argue, like just let it join twice, like who cares? But I think the bigger problem is not actually that it's complicated in terms of like there's more functions, there's more if checks. The bigger problem is you've created an embedded language. That's by a loose definition of language, but there's a lot of knowledge stuck in here. This friend link, that Atom friend link, and the Atom user, those are like little globals in this microsystem here of like, if you try to reuse them in the wrong way, like you won't realize what you've done. And we refer to them in this like from friends of, right? We say, give me where the friend links, align with this particular user ID. And that's a language. There's semantics there. Friend link means something in this context, but maybe you have a lot of different ways to be related to a specific like link, friend link, or anything like that. And so this is the example of like, people can't just come and work on this. They have to know things. And a big part of composability is that I would say maybe the right kind of composability implies extensibility. And this is really important. So this kind of code, let's say somebody says, you know what, we need analytics. We want to send out our data to like, I don't know, PostHog, or we want to send out metrics to New Relic or something, or Datadog or Sentry and AppSignal. And they're like, go and make sure that all of our events that happens to users are shipped off to this analytics platform. There's only one way to do it. If this is what your system looks like, there's only one way to do it, and it's to put another function call in all three of those functions. You might get like fancy with it and make that function say like track analytics, and then decide in the function what to track. But you have to change all of those things. There's really no other way to do it. So this brings us to Ash. A lot of this, we have a lot of motivations for building Ash, but this kind of thing, these problems that crop up with the way that we build our software, it's kind of death by a thousand cuts of things that can't plug in, and knowledge that you've embedded into these systems without first classing that knowledge, that drives us to build Ash. So I want to talk about actions. We're going to do a bit of an introduction here. There's supposed to be an image here of a resource, but there isn't. Anyway, in Ash, we have a concept of actions. Actions live in resources, and resources act kind of like the nouns in your system. They look just like an ecto schema, just a little different. And they act like nouns and sometimes like concepts, right? So like the question I like to ask people is like, what's a module for? Like, for anything, right? It's up to you. And a resource is very similar. But resources have clear interfaces via actions. Everything goes through an action. And these actions are declarative verbs. So you can see we've got a read action, and we can use that. We can call a function to list all the tweets, and we can pass in a query and filter it and all that sort of stuff. It's kind of table stakes behavior. But we also have things called calculations. There's a lot of building blocks, but I want to highlight a couple of them. Calculations are an example of a way to compose like computed properties in your application. So the full name of a user, I mean, first off, if you know anything about names and countries and other places in the world, like this is not a good thing to put in your application. But this is a great example of a computed property, so we use it. And this expression, Ash reserves the right to figure out how and when to run this. Maybe it'll put it in SQL, so maybe it looks like this. If you ask us to like load the full name, But in this case, I actually lied to you a little bit because it won't put that in the SQL. It will do that in Elixir land. There's no need. It will select first name and last name and connect them in memory in Elixir land. So this level of flexibility arises from, you don't tell me how to get the full name. You just tell me what full name is, and the framework will figure it out. The framework will decide. And we see this kind of thing in like databases all the time. You ask for the data, the planner tells you how it's going to get the data. You can hint it, but you don't really get to choose. And that simple example is great, but if you look at these can get very complex. And that's because the domain that we're representing typically gets very complex. And you can see here, like, we have the ability to sum related information. We have this count of likes, for example. And we have is friend of. That's a parameterized calculation. So you can say, and now you have this reusable piece of logic that's not just used to filter or not just used to sort. It's instead, you've isolated the concept in a way that we can use for all kinds of things. We can use to load it up as a field in the API. We can filter, we can sort, we can compose other calculations with it, right? So this is a really powerful concept, and it all comes from this declarative nature of building the bits of our application. And we also get interfaces. So I talked a bit about actions. This is an example of like a pretty common type of action. And this action, like, I think you kind of might ask yourself, why would I use an action and not like a function? Why wouldn't I say like def feed that takes a for user and then builds a query and returns the data? And that's where we get to that composability and extensibility conversation. So let's go back to the example where it's like, hey, we need to track analytics for all of our events of a certain type that happen, or something like that. In Ash, I can just attach a hook. I can say, like, this changes block lives in the resource, and I'd say, hey, send an analytics event. And now that's attached to any time we construct a change set for this resource. I'm going to call this, it's like a plug. If you've ever used Phoenix routers and plugs, you can just hook into that, and now, like, I don't have to go change the like core logic of what it means to make a tweet or to like a tweet, but I can horse that all into our data platform or whatever very easily. And this extensibility is an important aspect of building software. All right, I'm going to switch tracks here. Now, I've given you a little bit of an introduction to like kind of the why behind Ash and the kinds of ways that we try to solve some of these problems. There are users that we have, people in production that are here today, and we are, I think we're in a phase now that I think is very exciting. So I'm going to talk a little bit about where we came from, where we're going, and what's kind of going on. So past, present, future 1.0. Some of you guys might know the story, but that was an accident. So I have this great little tool. A lot of people like it. It's called GitOps. You get to say, pick a new version for my software based on the commits. And if you don't look at the new version, you might not realize that you just shipped 1.0 when you meant to ship like 0.3. And then the next day, you might contact the people at Hex, and they might tell you that they're pretty strict about the rules, and that 24 hours after, I think it's 24 hours or 8 hours or something, you can't just like undo that. You can revoke it, but then 1.0 will forever be revoked. So I was like, we're doing it live. So we just launched 1.0, and it was all good. We had a big disclaimer on our README that said, I know it says 1.0, but Okay, 2.0. Real, actual, big, very happy release. It was a whole production. And the focus was on integrated features. And we're still in 2.0. This is the phase we are currently in. I'm going to just list some of these things. I'm going to highlight them later. I'm not going to explain all of them. I don't want to bore you guys to death. New types, OpenAPI. We're all familiar with OpenAPI. Many of us are, I mean. AshOban, state machines, complex calculation composition, anonymous aggregates, bulk operations, and atomics. I thought there was one more in that list. There we go. So we're really focusing on driving home these heavy-hitting features that people are using, that people need, so that when they are power users getting to the edges of the things that we've built so far, they are not kind of stuck in a lurch. And that's way more important to me right now than going to like spread the word and get every newbie on board. That's not to say that the onboarding process has been neglected. We have a pretty decent getting started guide, but part of our philosophy is prioritizing current users over like the attraction of new users, because people who have thrown in their lot with us, people who have invested time in learning the software that we build and have put their business on the line, or I mean, your business is your livelihood, put their livelihoods on the line, essentially betting that this thing will help them go faster, right? To me, that is something I feel very responsible for, and something that I'm always going to prioritize, making sure that those users have the things that they need to continue. And what that means for everybody here is that if you ever become one of those users, you're part of the club that we take care of before we try to make like a flashy whiz-bang thing that might attract a new user. So it's a pretty important philosophy, even though like, sometimes it means that I have to focus on these really big, heavy features instead of things that make like the website look nice or the getting started good guide better. So we've also focused on growing the core team. We have James Harton. So I meant to put his Twitter handle up there, but you can find him on Twitter. He built AshAuthentication, which has been a huge value add for Ash users. And Josh Price, who is our kind of the father of this whole initiative. He's been funding the project and bringing it to our customers, and kind of just being the chief evangelist and kind of pulling for the business side of this whole thing. So we've also focused on growing the ecosystem. While we're listing long lists of things, we've released lots of packages. Spark is a DSL building tool. AshAuthentication, I talked a bit about that. It's like kind of mixed Phoenix Gen Auth, but for Ash. AshStateMachine, it's a common thing that we've seen. We'll talk a little bit about that. And we've got tons more stuff on the way. And our goal is to make this an ecosystem of higher level packages and building blocks to let you go further without having to like reinvent wheels. I'm going to highlight some features of 2.0. So these are not everything, but it's some fun bits. We've got a JSON API extension, and this is actually like in a given resource, that's the whole thing that you need. You might tweak it, you might customize it, like in the real world, you might add stuff to that. But that defines a JSON API, does all of the work. It handles all of the controlling logic, the validation logic, everything. And what you can get from that now, thanks to one of our contributors, you've got open API specifications automatically generated from your resources. These are documented. The parameter types are all explained. It all is just like, it takes one line of code in your router. So it's a pretty powerful thing to just kind of get for free. That should say AshStateMachine, because this is AshStateMachine. So this is a really common thing. We see this all over the place, which is you essentially use some piece of state to represent a workflow or something like that, and it's an isolated workflow. And state machines are a super powerful concept, so we wanted to make them integrated directly into resources. And so using our state machine logic, this will automatically validate that the transitions that you do are allowed transitions, and that it will give you tools. I should probably have included a picture of this, but you get mermaid charts emitted of the possible states of your resource, which is great for auditing or just explaining. Rich calculation composability. So this one, I debated whether I was going to keep it in because it is a little bit complicated, but it's very important to know that we don't want to do like a surface level calculation engine that as soon as you like have to do something complicated, you're sort of stuck. So we have things like, you can see a more complicated example of an expression here. That con statement will be turned into a case statement in SQL. And so you can write like really rich calculations. And you see that overdue calculation on the bottom is actually referencing the other calculation, right? So you can build up this little, the sort of map of concepts, and you can isolate the bits that matter into their own calculations. But something that matters is not everything we calculate can be done in SQL. And look, there's another bug in my slide. I'll tell you guys a story later about how I had to copy this all from Keynote in 10 minutes or all from Obsidian to Keynote in 10 minutes before I did this talk. What should be there is a picture of a module that has a calculate function in it. And what you can do is you can express dependencies on other calculations, and the data that you get in that module will be guaranteed to have those calculations and those relationships loaded and hydrated for you. So you can just focus on the work that you have to do, not the how to get the data that I need to compute this property. Bulk creates. So this is the first of kind of like a whole series of things that we're doing around bulk operations. So the way that this works is we take your declarative create action, and you can just turn it into a bulk create action without changing the definition, because we know all the rules for it, we know how it's supposed to work. So all you have to do is essentially stream into that action, and you'll get a batched bulk insert into the data layer, and it supports upserts too. So this is great because basically you define what it means to create to create a user in your system, and then if you want to do CSV import, you just stream into bulk create, and that's the extent of what you need to do to have bulk operations in your system. So it's pretty powerful. And atomic updates are the most recent thing, and we're going to be really pushing the atomic pattern over the next couple months while we build up to 3.0, I mean. And atomic updates are kind of table stakes. If you're used to working with something like Ecto, you expect to be able to increment things, and you expect, and the thing that's interesting about atomics in Ash is that we leverage this information essentially to determine if an action can or cannot be done entirely atomic. And if it can, it will be performed that way. And what that includes validations and changes, like customizations to the action and policies. And so what that means is, because all of the things that we have can be turned into expressions, they can be lowered into the insert statement into the database and validated in one atomic operation that you didn't break some invariant of your system. And so you actually get the ability to take any of your create or update actions and do them atomically if you need. And if you don't want to do that, you can lock. So there's a lot of flexibility with the way that you can actually interact with the underlying data store. All right, what's left in 2.0? So we have bulk updates and destroys. We have bulk creates. Bulk updates and destroys refer to streaming records in, but we do have another kind of bulk operation that we're going to do after that, which is from updating and destroying from a query. And really what that is like the synthesis of a read operation and a update or a destroy operation, such that the policy rules and the operations are validated against the rules of the query, or the rules of those two actions respectively. Atomic upserts, this one's kind of mechanical. I just need to put the elbow grease in. I'll probably do it next week. But we have atomics for updates, but you need atomics for upserts. Like if I want to create this thing or increment some counter by 1, that kind of thing. Fully atomic actions. I talked a bit about that a second ago. And so that includes, atomic enforcement of validations and atomic implementations for changes. And then we will get to 3.0. So we're a couple months away from this. I thought we would be closer. In my talk, it was exciting announcement. I thought that was going to be 3.0 is out, but takes work. So we are shifting focus in 3.0. We're shifting focus to developer experience because I think by the time we have these features done, we will have well covered pretty much all of the main anything missing that somebody might ever encounter. And so we're focusing on developer experience, things like generators, high quality generators to get started. That's one of the hardest things that people are dealing with right now is they have to copy stuff from the getting started guide into files. And that's just not a good experience for new people or even experienced people that are just trying to start a project. We also really want to focus on best practices. So Ash kind of pushes you towards a lot of different patterns, but you can technically do anything. You can attach any functional behavior to any bit that we do for you. And so we really need to build up a set of cookbooks, tools to illustrate. Here's how we would suggest that you build this kind of thing. Better defaults. So part of 3.0 is basically going to be just release. We've realized a few things. We chose the wrong behavior at the beginning. This is a common problem. And so we're just going to use this opportunity for 3.0 to switch out some of those defaults and to focus on making that default experience better. Tooling, this is a big one, and we do focus on this already. Like, we released a tool for visualizing the policy rules of a resource. That was like, I built and released that in the lobby over here 2 days ago. But we really want to have more things like that. And we also want to focus on error handling and debuggability. So this is a common issue with the kind of inversion of control flow frameworks, like what Ash is, which is that when something goes wrong inside, it can be difficult to know why. And so I pretty firmly believe that we have the tools to make error handling and debuggability better than even if you hand wrote it, but that requires a lot of attention to detail. It requires making sure that the context is available anytime anything goes wrong and pointing users at the solution. That's all that I have, and one more thing. It's on the screen in front of me. I would like to welcome Barnabas Jovanovics. He's our 4th core team member, and he came all the way from Austria to be here. Where are you at? There he is, right there. Yep. So he has been a lifesaver for me. He's always willing to just roll up his sleeves, get his hands dirty, and fix issues, and like tackle a lot of things that are maybe less glamorous, but just need to get done. And he's also just constantly helping out people in the forums and in the community, just like he's a machine answering questions. And so I couldn't do it without him. So I'm just very happy that he was able to be here with us today. And that's the end of it.